Hi, I'm Chandrasekhar Gupta. We are discussing programming concepts. Before moving further, I want every one of you to recite this line. United American States can be largest trip among cities. There is a speciality in this line. It actually represents the order of precedence of operators in C. In addition to that, first letter of every word refers to a set of operators. U referred to unary operator, A for arithmetic operators, and then S for shift operators, C for comparison operators like greater than, less than, and so on, B for bitwise operators, L for logical operators, T for ternary operator, A for assignment operator, and finally C for comma. Unary operators will be having the highest precedence and it gradually decreases over comma. Comma is having the least precedence of all these operators. Now, after remembering precedence in this order, let's try to look at one more factor, which is associativity. Associativity actually refers to something that if you have an operand, let's say A, and if you are having two unary operators to it on the left and to the right, which operation has to be performed first? Either it has to proceed from left to right or right to left. That is decided by associativity. You need to remember only one thing here: unary operator, ternary operator, assignment operator. Only these operators flow from right to left, and all the other operators have associativity from left to right. Let's try to understand operators with the help of this example. United American States can be largest trip among cities. Or you can even remember by you ask black. Just add a ternary operator here. So, before unary operator, you are actually having other operators that are function parenthesis, array brackets, selection operator, and dereferencing operator. Don't worry about this, we'll talk about this later on. Now, after that, we have to talk about unary operators. Unary operators are actually associated with a single operand. So, increment or decrement operators, or negation operator, or size of, type, ampersand, where we get the address of it. All of these are unary operators, and all of the unary operators are of the same priority. And after understanding unary operators, it's time to go for arithmetic operators. In the case of arithmetic operators, we'll give first priority to multiplication, division, and modulo, and second priority will be given to addition and subtraction respectively. In the case of shift operators, both the shift operators are having the same priority. In the case of comparison operators, greater than, less than, greater than, equal to, less than, equal to, all of these are having the same priority, and equal to and not equal to comes in the second priority list. So first priority will be the greater than or less than signs, and the second priority is equal to or not equal to. And then we are having two bitwise operators where AND operation is given preference over XOR and OR operation. So these are bitwise operations. And then we are having the logical operations where it is used to connect two expressions. So here we are actually giving preference to the AND operation followed by the OR operation. After this, we are having the ternary operator. So the ternary operator is used as the replacement to if else, that we will discuss later on. Now after this, we are having the assignment operators. Suppose for example we are having A is equal to A plus 1. It can be written as A plus is equal to 1. When both of these operands are same, we can actually skip writing it once more. Suppose for example A is equal to A star 5. It can be written as A star is equal to 5. S is equal to S plus 7. S plus is equal to 7. These are the assignment operators and all of them are having the same priority. Finally, we are having comma. Now, these are all the operators. Finally, you need to remember that unary operator, ternary operator, and then assignment operator. All of these three operators are having right to left associativity. All the other operators are having left to right associativity. So you just need to understand unary, ternary, assignment operators are having right to left associativity. That's it. Now, after dealing with all the operators, let's try to look at an example. Let's try to understand with the help of this example. This example is actually having only this comparison or arithmetic operators. We know that in comparison operators, multiplication, division, modulo are having higher priority over addition and subtraction. So we actually check for these three operators initially. If found, they will be performed first, followed by this. Now, if we just go into the expression, initially we have found the division operator. This operator actually returns the quotient. So if 9 is divided by 2, 4 will be the quotient and 1 will be the remainder. So 9 modulo 2 will be 1 and 9 divided by 2 will be 4. You need to remember that if you take a decimal number, suppose for example you take a number 525, you divide with 10, 52 will be the quotient and 5 will be the remainder. So if you take a decimal number, you want to separate the last digit, you can take the modulus of the number. You can take modulo 10. It will actually separate the last digit. If you take a binary number 101 and if you want to separate the last digit, you can take modulo 2. If you want in a base n system, if you want to separate the last digit, you can take modulo n. As simple as that. Just remember this logic. This logic will be actually used to find in reverse a number and so on. So 9 divided by 2 actually returns us 4 and 7 into 5 actually returns us 35, and we are having the addition and subtraction signs respectively. Now this associativity is left to right. So the operation has to be performed from left. 4 plus 35 is 39 minus 8. 39 minus 8 is 31. So 31 will be the answer of this. Let's try to understand this with the help of one more example. This also is having only the arithmetic or comparational operators. We know that here multiplication, division and modulo are having higher priority over addition and subtraction. So we have to search for these operations initially, we have to perform them and then we have to find the other operations and finish this according to their associativity from left to right. So initially I need to find these three operations. When I just scan the expression, I am having a division operation here and I am having a modulus operation here. 2 when I divide with 7, the quotient will be 3 and the remainder will be 1. This will be 3. 8 when I divide with 5, the quotient will be 1 and the remainder will be 3. So this returns me 3 and the other expression is as it is. Now it is having the left to right associativity. So 5 plus 3 is carried out first, 8 and then 8 minus 3 will be 5. The result of this expression is 5. This is how the expressions are evaluated in C programming language. Now, after understanding the evaluation of expressions, let's try to understand one more concept in data types, which is called typecasting. In typecasting, we are having two types. First one is implicit typecasting and explicit typecasting. If you just remember, in the last video, we have discussed data types are similar to boxes of different sizes. So accordingly, they can store the range of the numbers. Integer is a small box and floating point is a big box. So if you want to place integer in floating point, it can fit exactly. But if you want to place floating point inside an integer, it cannot accommodate it. There will be a loss of information when you try to transfer the data from floating point to integer. You need to remember this. You can just understand it with the help of the sizes of the different data types. A smaller data type can be placed in a larger data type, but a larger data type cannot be placed in smaller data type. Just try to understand this. Coming to this concept, let's consider a floating point variable b. Now you are trying to divide an integer with the help of a floating point number. Here, in this case, integer will be converted to floating point because 2.0, this is a floating point number and this is an integer. As we have seen, a smaller box can be placed inside a larger box. So when you are having an expression between two data types, for example, smaller data type and a larger data type, the smaller data type will be automatically converted to the larger data type for accurate result. Here 5 will be converted to 5.0 divided by 2.0. So instead of storing the result as 2, suppose for example if you divide with 2 with 5, the quotient will be 2 and the remainder will be 1. But in the case of floating point, if you divide with 2.0 with 5.0, it will be 2.5. So the quotient is 2.5 and the remainder is 0. Now B will actually store the value of 2.5. Here, even though 5 is an integer, it has been converted to floating point type. So implicitly the change has been occurred. And when the change occurs is, if you are having a small data type and you are having a large data type, smaller data type will be automatically converted into larger data type, and this is called implicit typecasting. Now let's try to understand the explicit typecasting. Now you are explicitly trying to convert 5 to floating point number. So integer 5 will be converted to 5.0 and this will be assigned to this floating point number. As you are converting to a bigger data type, there will be no loss of information. But if you do the vice versa, there will be information loss. This is all about typecasting. Now you need to understand some points if you are working with C programming language. Consider a statement. Now the statement can either hold a true or false value. So if this statement is true, then it will return 1. If the statement is false, then it will return 0. So every statement or expression in C programming language is either associated with true or false. So it will be either associated with 1 or 0 respectively.